Hi everyone. So we're back, and in this module, or super module, I should say, we're talking about some very advanced topics in Swift. So Jack is going to explain some ideas and some topics that he believes are quite important in Swift. I'll chime in and ask questions at the appropriate times when something doesn't make sense to me, which might be often. So let's learn about some things that go beyond the very basic things that we saw before.
Yeah, so we went through the basic things, but of course Swift has many more features that make it a modern and pretty cool language. And hopefully today we can go through most, if not all of these, and also provide some extra reading for some more advanced topics that we might not need for this course.
Now, some of the things we talk about may not actually be necessary for this course. So think of this as an advanced topic. Now, some of the items might make your life a lot easier, right? There are some items, actually a few items that I think are going to be coming up that it's good to actually listen to this lecture, but if there are items that that you may not want to explore, we'll provide links and make it optional for people to look at.
Yes, so don't worry if you get too lost. We'll provide some reference material, and everything's in the Swift book from Apple as well, and that's a great reference always. Cool. All right, so our first topic. We want to talk about optionals. So we briefly went over optionals in the previous module, but you never really sort of saw the power and really why do optionals exist, right? Like this idea of an optional, it's pretty interesting. So again, we'll start a playground, call it all about optionals.
And so I can maybe start asking a question that I'm sure the audience has. We saw optionals existing because, for example, you could have a function or a parameter that's being returned. You don't know if that something is being returned, so nil could be an option being returned. So that in that context, it made sense. Of course, it's not clear as to how widely that might be useful. So
yeah, because I mean, it's not a new concept. Almost every language you can return nothing. As an option to pointers. Whenever there's a pointer, you can have a pointer to nothing, and then that's really a common thing. And in most languages, you don't need to really have a special sort of way to express that this can be nothing, because everything can just be nothing. But what makes Swift cool, what Swift optionals cool, is that it takes this idea, and by sort of having a concrete thing to specify that there can be nothing, the usefulness of it is the opposite, where then you have types that cannot be nothing and are very safe. So I guess this goes into a little bit of Swift's philosophy, where it wants to be a safe language that prevents problems that may occur before they occur. And one of these problems that you may come across in programming is when you access a value but it doesn't exist, and then your program just crashes. And
like
with
a nil pointer, essentially.
Yeah, if you get a nil pointer but you weren't expecting it and you access anything on it, the program will just crash, which is a bad experience. And so optionals, let's have some examples, like maybe string, which is a string optional. Optionals let you know whenever you see this question mark, and wherever it makes sense to return nil, that it's an optional. It can be nil. And what this does is it forces you to be safe. As we saw before, this could be a string. Hi. But when I print it, print takes a string because it has to print a string, right? This will print an optional. So print is not the best example here, but say we had a function that required a string, and you pass in an optional, it will warn you. For example, if you want to count the length of a string, it won't let you, because count takes a string. So if you want to count a string, it only makes sense if you have a string. And if you don't, it's going to tell you can't do this. So the compiler forces you to be safe just because it's an optional. So yeah, you have to check it. You have to check if maybe string. Sorry, we don't need parentheses here. Is not equal to nil. Then you can call it and it'll be safe. So you're forced to check it. But this will still error because you're still passing optional, and you can use this exclamation mark, the bang, to forcefully unwrap the string and make it now a string. And now you have an error. Why do we have an error? Because you can't, because count is a terrible example, and it's meant for arrays.
Okay, so just to address this, we need to figure out how to count the
we
links in the string.
will. Oh, sure. Let's do that
Let's
too.
do it properly.
So I'm pretty sure string has like a length property. No, it doesn't. How do you count a string? Oh, right, because in Swift 2.0, this is new in Swift 2.0, and they changed strings to be a collection of characters. So you can't count a string, but you can count its characters. So if you do string dot characters, there we go. Should be let us count it. And in Swift 2.0, we don't do count like this anymore. We can directly do dot count. And it'll tell us you have 2 characters.
There we go.
There we go. But notice we also needed the exclamation mark here, which means we forcefully unwrap it, which can cause a crash if it is a nil. Because basically here you're saying it's not nil, and I'm going to access it anyways. So if we remove this and made it sort of unsafe, and we change this to a nil, our program will actually crash like any other program. So the exclamation mark is basically dangerous.
Right.
It's like danger.
So the whole point of optionals is to avoid all this. Essentially,
Mhm.
you just declare a string, and then you can then count the characters. And the whole idea is that you know the string can't be nil, so therefore you can count the characters.
Yeah, and it'll never fail, and your code will be safe, and you will be sane and happy, hopefully. But see, as you can, optionals will come up quite often, and as you can see, doing this every time is kind of annoying, right? So there are many ways that Apple has, that Swift allows you to simplify this process. So if you do this, it becomes safe, and the best way, sort of the most common way, is called optional binding. So there's a syntax you can use called if let. So let defines a constant variable. So you can create a new variable called like definitely a string. And if you assign it to maybe string, and that's basically the argument to the if statement, this will only pass if this is not nil, and then the value is unwrapped from the optional into a proper string and assigned to definitely string. So when you look at this, it's a type string and not a type string optional, such as maybe string. And actually, this is really cool. Inside this if statement, you can now directly count definitely strings characters because it's no longer an optional. And if it was nil, it simply won't go into this block. So you can actually have an else. Else. And we can say it's nil. And so this syntax here is optional binding. And you can see if we set it to a string, it will go into the if statement, and this will be assigned to the unwrapped value of this optional, and you can directly use it. So this is much better than here because, again, you don't want to use, you want to avoid using the exclamation mark because it sort of signals a warning, and this is one way in Swift that allows you to do it. And this is also, let's bring back, a while ago we talked about guard, the guard statement, and why it's useful with optional binding. It's because, say characters was optional, say string had, even though it's not here, then you would have to keep if let unwrapping and have multiple layers down and down, sort of have a pyramid of doom, as we call it, of brackets. And guard lets you get out of that. Guard lets you guard the fact that, guard lets you unwrap and else you simply break. So when you do this, the difference is, and now it does sort of the same thing, and we can't return inside a storyboard, but pretend that you can. Guard lets us stay inside the outer scope instead of in a new inner scope. So after you did this optional binding, you're now stuck inside these brackets. And if, say, this was really important, and you have to unwrap it first, all the rest of your code will be inside level. By using guard with optional binding, it lets you return if it's not a nil, and then for the rest of this function, this method you're implementing, you can stay in this golden path and not be trapped inside the brackets. Okay. And so, yeah, that's just the interesting part. That makes guard just that much more interesting to use when compared to if.
So is this something that you must implement in your code? No, but it's something that makes your code more elegant.
Yes. So there's another type of optional that lets that you can define as, and it's called an implicitly unwrapped optional. So I'm talking a bit about unwrapping here. When you unwrap an optional, you're simply taking it out of the optional. So say like an optional is maybe an object, and then it's sort of like wrapped up and you don't know. And when you unwrap it, it's either something or nothing. And if you take it out, then if there's something, then you can, and that's what the exclamation mark does. It takes it out of the box, and now it has to be something. If there's nothing, it will crash. There's a type of optional called an implicitly unwrapped optional, and we'll call it most likely string, and it's of string type string exclamation mark. And what this means is this should be a string, but it doesn't. It's still an optional. But since it should be a string, you can use it directly. So I can count it directly without unwrapping it. And what this means is, if it was a nil, which it should never be because it's an implicitly unwrapped optional, it will crash. Because when you call it, it basically unwraps it for you. And you can still check it for nil and stuff. It's just whenever you use it, you can use it like a non-optional because it unwraps it every time. And what this allows you, this has some use cases as you'll see later in the course. Just keep in mind when you see a optional with an exclamation mark, it's also an optional. It's just a bit more convenient to use, but also a bit more dangerous. Because again, the exclamation mark is always a sign of sort of danger. Yeah.
I don't think we can leave that, because I think a question that the audience will have at this point is, how is this different than a non-optional? If it crashes when you sign it to nil, and in every way it's a non-optional, then what's the difference?
Yeah, so the issue is, so this is more of I want to say, you should, if you're writing pure Swift code, you would want to avoid these. All the cases where you would use this is either because you get a value from Objective-C, and Objective-C, everything is pointers, and everything can be nil or not nil. So when you get something, it's going to always be an optional. And in the case where it shouldn't be an optional, you could use one of these, where Objective-C is going to give you an optional, and you're just going to assign it to a variable with a bang on it, and then you can use it as if it's not optional. And it creates convenience there, because you don't want to directly unwrap the value. There's other, as we'll see later on in the course, say you connect, when you build interfaces, you can have an object that you connect to an existing interface, and it might be there, but it will, since you connect it yourself, you know it will be there, but it can't be non-optional, because there's still the possibility of it not being there.
Essentially, you have an Objective-C block that is different than Swift, and it's returning something that is an optional, but you don't want to deal with it as an optional.
Mm-hmm.
So essentially, you have this, what in this case, this allows you to treat it as a non-optional
Mm-hmm.
going forward, but you can assign it to an Objective-C.
Yes, because Objective-C does not have the concept of optionals, so it can't return you a non-optional. It will always be an optional that it gives you. But there's functions that you know, because Objective-C knows as well, that it will never give you an optional, yet it will still have to give you an optional just due to the language.
But can't you actually have an optional assigned to an input from Objective-C?
Yes.
And then unwrap it as a separate variable? So this is just doing that in one step.
This is just creating convenience, yes. So you won't have to, after you see this, it's most likely a string. So in your code, you should use it as if it was a string, and you shouldn't check. If it was an optional, you would still want to check. And it's sort of just being more expressive with your variables.
A very good point that you brought up then is, when you're dealing with Objective-C, everything is, at least every pointer is optional, right? Every pointer can be nil. So that's something to keep in mind if you're creating interface functions.
Yes. So with the release of Swift, Apple's tried to fix that by letting developers audit their Objective-C code, and so there's a way now in Objective-C to basically specify that a pointer cannot be null. And then when passed to Swift, then it will actually pass a non-optional.
Nice.
But that's up to the developer to implement that. So in majority of cases, at least current right now, you'll still get an optional back from Objective-C. But there are ways to fix that. Yeah. So the next topic I want to talk about is optional chaining. So this was called optional binding. And we need an example to sort of explain this. And this is good. And hopefully this example would also sort of enlighten why optionals are really cool and good. All right, so we're going to delete this. We're going to find some classes here. And we'll take the common example of a car. But when I think about a car, I think about the cup holders in the car, and that's the most important sort of feature, right?
Okay.
So let's define a class for the cup holder. And it can hold some cups. It can hold like maybe an array of cups. And we'll just assign it with strings indicating what's inside the cup. So what you have now is cup holders, the capital string, and it's initialized, and it's optional because it may not have cups in it. And it's initialized to having no cups. And then you have a car, and the only thing we really care about the car is its cup holders. But I mean, there can be cars without cup holders, right?
Not good ones, but sure.
Yeah, exactly. I mean, we have to consider all cases here, right? I mean, personally, I would never buy a car without a cup holder, but it's a possibility. And so when you create a car, it can not have cup holders.
Right.
So now if we create a car, if we instantiate a nice car, okay, well let's create a cup holder for the nice car will be a car, and we'll give it some cup holders because it's a nice car. And then we'll also have a less nice car, maybe an old car. I guess old cars have cup holders too. Let's pretend old cars did not have cup holders. That simply does not have cup holders, and we won't have to assign it because it's defaulted to nil. And now, well, we don't even need to talk about the old car. So this new car with cup holders. Now, say I wanted to place a cup of Coke into the cup holder. How would I do that? This is pretty annoying because the car may have a cup holder, and the cup holder may have an array of cups already. So what we've seen before is we can use optional binding to drill into this. We can say if let cup holder equals to nice car dot cup holders. So if it has cup holders, we want to check if it has cups equals cup holder. This is sort of you're starting to see this pyramid I was talking about. And if it has cups, we're just going to stick it in the first. We're going to stick our Coke into the first slot in the cup holder. If it doesn't have cups, which one here? It has to be a variable to allow us to change it. Let's just finish this for now. Then I want to assign, if it doesn't have cup holders, then we'll give it a cup. This has to be a var as well, because we're mutating. These are not constants, because we're changing it inside the code. Cup holder dot cups is equal to just a new array with our cups. Right? So, I mean, I guess if it already had cups, we don't want to do this. We want to probably append it. We want to add our Coke into the array. All right, so this is pretty annoying because not only whenever you want to place a cup in, you have to do all this. If you want to see what drinks your car is holding, that's really important. You have to do this whole thing again. Just to check, you have to check if your car has a cup holder, and then check if it has cups. And I'm writing the same exact code again, but I mean it's for a different purpose. And then now we can check if my first cup is a Coke. And if it is, I'm really happy. Else I'm sad. Swift has a better way to do this. Gladly, or not gladly, but yeah, that's really nice. And it's called optional chaining, and it allows you to chain these sort of, because when we're doing this, we're basically drilling into each optional layer, and you can actually chain these up, and it will. Well, I'll just show you. So we can directly check what's the first cup by doing nice car. But dot cup holders. We put a question mark there to see if it has cup holders, and then we can access cups. We put another question mark there, 0. And this gives us actually a Coke. That's pretty cool. What is this doing? This is checking if it has cup holders. If it does, then it checks cups. And if it has cups, then it takes the first one. And that's really nice. If at any point there was it either didn't have cup holders or it didn't have cups, like if we just didn't do this assignment of cups, it will be fine. It will give you nil. So this is actually an optional string. And it will just exit and tell you, oh, there's no first cup in here. And this is very useful and can be used in many places. And even better is you can actually assign in the same way. So instead of doing all this, you can do nice car dot cup holders dot cups dot append Coke. And this will actually not do anything right now because we actually don't have cups here. So say we first set up some cups, an empty array of cups. Now you get Coke in the car, and we're happy again. Because if the cups didn't exist here, this would fail, and so you wouldn't add the cups. And here you're pretty sad. It doesn't even go into this part, so you're sad out here. Yeah, so this is a very cool way, and as you can see, you can even use this when indexing arrays, and this works as dictionaries as well. So if you have an optional array, you can use optional chaining to index it, because the index is sort of like a function call. It's just asking for the first one.
That's very neat, because that can save you, especially if you have a lot of parameters you're checking before you execute certain statements. It just saves a lot of time.
Yeah, and it's very safe. So here, same idea, you can actually assign it like this, which is incredibly cool and useful. Yeah, and so this causes your code to not necessarily work. Oh, it's because I have this random these brackets from the function call. It'll still cause your code to crash. It's not initialized. So if it started off with a sprite, you will replace the sprite with the Coke. Because the array was of length 0 and you were trying to access it, so you crashed. Yes.
Interesting point. Mm-hmm. You have this cups array was not nil, but had length 0, which is that's something to also check for that assignment as well.
Yes, so that's it is indeed an interesting point. And it's a difference between arrays and dictionaries. In arrays, when you access them, say array of strings, it always gives you a string back. It doesn't give you an optional string, even though, like, I guess logically, say you had an array of 3 values and I asked you for the 4th value, you could probably give me nil, right? But instead in Swift, by design, the string directly crashes if you access out of bounds. Whereas in a dictionary, if you access a key that doesn't, whenever you access a dictionary, it always returns you an optional. So so if you give it a key that doesn't exist, it will give you nil, which is very interesting. And yes, so when using arrays, you have to be a bit more careful and check the length and the bounds of the array. Okay. So see, with this example, I hope it sort of demonstrates why optionals are useful and how Swift manages to sort of keep the syntax nice and crisp. Even with this concept of optionals. And this line of code is actually really neat because just through this line of code, you can sort of see that cars might have cup holders, which might have cups, and you're sort of grabbing it like this in a safe manner as well.
I'm wondering, is there an easy way to so these checks are checking if these variables are nil, but is it possible to check the size of an array? So if you wanted to set the initial one to be equal to Coke, we could actually detect that there's at least 1 cup there. Yeah, so the same way the size would be is sort of just a function call, right? So you can keep chaining it down. So let's say if we wanted to check if nice car dot cup holders, and again we don't need these brackets. I'm just going to remove them. Dot cups and then dot count. If it's greater than 0, then we do this. Else we can do something else. But in this case, so it will go in and do something here.
And yeah, so you can keep chaining it down as far as you want and call functions upon possibly existing things. And as long as it exists, it'll keep going down and calling the functions. But in any part of the chain, say if our car is all of a sudden not that nice, and we remove this cup holders, all this code would still run, except every time you checked something or did something, it would just give you nil, because your car now has no cup holders.